Hello. Let's go through Learning Target 722, which is about the properties of rational exponents and simplifying our radicals. So what we're going to do today, we're going to kind of build on for the next couple days, and we're going to start with our exponent rules, which is a review from first semester. So what I want you to do right now is pause the video, and I want you to just try to see if you can simplify these three problems. See if you can remember what to do with the exponents, and then push play when you're ready to see. So for each of these, we have something different, a little bit going on. This first one, we are multiplying our variables, and we add exponents in that situation. So we have x to the 8th power here. And I'm going to go ahead and write that rule right here so I can remember. So the product rule, whenever I'm multiplying variables, I add exponents. Next, I am dividing here, and the opposite of multiplication is division, so instead of adding, I am subtracting. So I get x to the 6th here, and I subtract my exponents. And lastly, when I have a power raised to a power like this, I multiply those exponents, so I get x to the 16th here. And so now those rules are going to help us in our expressions today. And we have two more rules as well, the negative and the zero rule. Those don't come up as often, but they're important to know. So negative rule, whenever there's a negative exponent, we move that term to the opposite side of the fraction. So if it was negative on the bottom, we would move it to the top. If it was negative on the top, we'd move it to the bottom. And anything to the 0 power is 1. So now radicals can be written as exponents to a fraction. And so just a quick example here, the square root of x is the same thing as x to the 1/2 power. Square root of x, which there's an index of 2 here, is x to the 1/2 power. The cubed root of x would be x to the 1/3. The fourth root of x would be x to the 1/4, and so on. So these fractions here are going to help us with our radicals. And so the first thing I'm going to do is I'm just going to use my exponent rules, and we're going to fully simplify these. And they are fractions, but they all have the same denominator, so it'll be really easy for us. So right here we're multiplying, which means we're going to add our exponents. 2 plus 10 gives me 12 over 5. And I'm just going to leave that like there, or like that for now. I'm going to come back to that in a minute. So then the next one, we are dividing, so I'm going to subtract. 3 over 4 minus 1 over 4 is 2 over 4. And if you can simplify your fraction, you're going to want to. So instead of 2 over 4, both of those, the numerator and the denominator, can both be divided by 2, leaving me with a to the 1/2. And lastly, the one thing you want to remember about multiplying fractions is when you multiply fractions, which is what we're going to do here, you multiply the top and the bottom. So we get x to the 36 over 2 times 2 is 4. And 36 divided by 4, those can be simplified. So actually, if I do that, 36 divided by 4 gives me 9. And so this simplifies to just x to the 9th. So if you can divide your two numbers and it gives you a whole number, just convert it to your whole number. So that's kind of a review from what we did first semester, is just simplifying these exponent rules. The only thing that's new is you're going to be dealing with fractions. So we're going to come back to these in a second, like I said, but we have to talk about one more thing before we do. And that is how to simplify your radical. So, like I said, the exponents that are fractions can be converted to radicals. Those are directly related. So a fraction exponent and a radical are related. And so this middle step isn't really needed. It just shows you where it comes from. But essentially, like x to the m over n, you can simplify as x to the m power, which is on top, to the 1 to the nth, because you end up multiplying them anyway based on our exponent rules. And then we can simplify into this radical. So essentially, your m, which is your numerator, this becomes your power. You can see that there. And then n, which is our denominator, that becomes your index. Okay, so m, which is your numerator, becomes the power, and n, which is your denominator, becomes the index. And you're going to have to practice this and like look at this pretty much every time for the first couple days. And then once you get the hang of it, you'll just start to remember that pattern. So now let's go back to our examples on the front. And we have our examples here, and I'm going to convert them using that pattern. So again, your numerator becomes the power, your denominator becomes the index. So in here, I have my power here and my index here. So I'm going to rewrite it. I usually just start with a radical symbol. And I have my a. My numerator becomes my power. My denominator becomes my index. And that's it. So that's what we're doing today, is just converting back and forth between these. So numerator, power, denominator, index. So then here, this is why I said it's important to simplify when you have it as a fraction, because it'll save you a lot of trouble later when we are trying to simplify these radicals. If you just simplify it here, you are pretty much done. So again, numerator becomes your power. So I have a to the first, but I don't need to write the first power. And then 2 becomes my index, but I don't need to write that because that's our default index. So a to the 1/2 is just the square root of a. And lastly, I have my x to the 9th over here. I only have a power and I do not have a denominator, so I don't have an index, which means this is my simplified version. So I just keep it as x to the 9th. I don't have a radical because there is no denominator. So now what I want you to do is I want you to go to the next page. I want you to pause the video, try the 3 U-tries, and push play when you're ready to see the answers. And here we are. For this first one, you want to add your exponents, so you get 9 over 2. Remember, you don't need to write the index of 2 here because that's the default. Over here, I have the 5th root of a to the 7th. And then over here, the 4th root of x to the 27th. So now what I want you to do is I want you to go ahead and do the practice problems at the bottom, check the key to see if you are right, and continue on with the rest of the lesson. Thanks, everyone.